This webinar is Robot Smart Labs, an innovative approach for monitoring and managing rivers and lakes beyond 2020. And today it will be presented by Natalie Gilbert. So Natalie is the project manager at Thames 21 for a Horizon 2020 innovation project called INTCATCH. 47% of European water bodies do not currently meet good ecological status. Real-time water quality data from sensors are proving their value by providing an evidence base to enable effective tackling of pollution. During this webinar, Natalie will give us an insight into the INTCATCH project and the project's aims to revolutionise the way we monitor water quality in rivers and lakes, making it easier to combat the many pollution pressures they face. As always, there'll be time for Q&A at the end of the session, so do submit your questions in the chat box in the bottom left-hand corner of your screen at any point during this webinar, and I'll put them to Natalie at the end. So thank you for your attention, and please stand by as this webinar will be starting shortly.
Hello everyone, thank you very much for joining me on what's a gorgeous day outside. I appreciate that. So today I'm going to be talking about the Horizon 2020 INTCATCH project, specifically the contribution we hope to make to advancing the use of robots for real-time monitoring at the level of the catchment, so whole catchment monitoring. So what I'm going to do is I'm going to introduce the perfect storm, if you like, of need and opportunity that led to the creation of the INTCATCH project. And then I'll introduce to you some of the tools we're bringing together and also creating in order to tackle catchments in a more effective way. Before I go on to share some of the initial data that we're gathering with you. And it's very timely that we're talking about rivers this week. Here in London, it's London Rivers Week for the whole week, which is trying to engage people with their local rivers. So what I'd like to do, just to warm you up to the idea of rivers, is just ask you the question, how healthy is your local river? Do you even visit your local river? Do you know where it is? A surprising number of people actually don't know the name of their local river or where it is. So if you wouldn't mind, give me on a scale of 1 to 10 in the chat box, maybe the name of your river and how healthy you think it is, 10 being absolutely pristine and maybe 0 being really polluted. I'd be very interested to know. Obviously, rivers are a great place to visit. I think last week the webinar was on tranquility. Rivers can be great spaces for getting away from it all, as well as obviously very important for the wildlife that they sustain. So do you use your river? Do you go canoeing on it? Would you use it more if it was healthier? Or are you worried about it, like some of those pictures on the right-hand side of the screen there? Is there obvious signs of pollution? The bottom picture on the right is actually outside of the office where I work in London. As you can see there, it's completely green. That is actually a river, believe it or not. It's got huge amounts of excess algae growth due to the enormous amounts of nutrients in the water, such as phosphate and nitrate. So, oh, we've got some answers coming in here. The Wandle, 6 out of 10. Haven't found one yet, that's a shame, but I'm glad you're here. You'll see some pictures of rivers as we go along. 4 out of 10, okay, yes, so bikes and trolleys, yes, that's very familiar to me here in London. So great, lots of answers coming in. 7 out of 10, we're going to come and visit you, Richard, that sounds nice. Oh, 10, the River Ouse. Fantastic, so sounds like a lot of you are kind of at least aware of your local river and some of the issues it might be facing. So let's delve a little deeper into that. Here's another question for you. What are the main concerns about water quality that you actually have? Some of you might be practitioners in the water industry, you might know very well, so let me know, again in the chat box. Yeah, you might be familiar with some of these issues here, so the idea of industry putting heavy metals and oils and other chemicals into the water. Misconnections is one that you may or may not be aware of, the idea that plumbing from houses doesn't always go directly to the sewage treatment plant. Some of the surface water goes directly into your river, so well-intentioned DIY or rogue plumbers can actually accidentally plug your washing machines, your toilets straight into the river. So leading to wastewater going directly into the river. Is it an agricultural issue? Okay, so runoff from agricultural ground, toileting waste from wild camping. Okay, yes. Okay, so it sounds like a lot of you are in much nicer areas than I am, lots of agricultural issues. Not so important here in London, where we've got lots of issues with road runoff, for example. So diesel oil and things running off into the river, lots of sediment containing heavy metals and things. And you may not know in so much detail. It might just be a case of odours, visual pollution, plastics, things like that. Shopping trolleys, I saw one of you mention earlier. Or even just a concern, is it safe for my dog to swim? When I go out doing water sampling, That's a big question that I get asked a lot. So yeah, keep the answers coming. Septic tanks, yeah, that's another big one. Okay, great. So you might know the concerns that of the local rivers, but how to fix them is another question. So this brings me on to the INTCATCH project, which stands for Integrated Catchments. That's the INTCATCH bit. And what this project is actually aiming to do is basically broaden how catchments are monitored and who can actually engage in the monitoring. So that's the main aim of the project, and more about that later. What I'd like to do now is basically give you the background to the project. So as I was saying earlier, this sort of perfect storm of need and opportunity which led to the development of the project. So what you can see now is a map of the proportion of rivers and lakes in all the river basin districts holding less than good ecological status or potential. So obviously the darker the colour, the higher the number of rivers that are currently not achieving good ecological status as defined by the Water Framework Directive, which is the European legislation that governs the quality of our rivers. So as you can see in the UK, it's pretty red for most of England and Wales. So we're not doing too well, despite millions of pounds being spent on water quality monitoring. So what we're currently doing, I mean, we're great at monitoring. There's a lot of monitoring going on, but it's actually not leading to enormous sort of benefits for rivers. And there's several reasons why. So and these are the sort of the key areas why INTCATCH became created as a project. So the first issue we're trying to address is the way we actually monitor our rivers. So currently the way rivers are monitored, and our lakes of course, is specialist, costly, retrospective and low resolution. So specialist in that we send out an expert to do it. We send someone from the Environment Agency, for example, or a water company. They actually go out to the catchment and they physically take a sample, as you can see that guy from the Environment Agency doing on the left. That then gets sent to a lab, which is again costly, specialist. You might wait a couple of weeks for that data to come back to you, and then you get presented with a spreadsheet. A lot of the sampling is done at the ends of the catchments, so you don't actually really have any idea what's going on in the rest of the water body, just at the end of the catchment. So it's low resolution, it's not answering the questions we need to know to really help our river environments. How does it change on maybe a daily basis, you know, in response to a rainfall event where you can get a lot of what we call the first flush, which is a lot of pollutants and sediment being washed off our fields, off our roads, directly into the river. And it doesn't help us decide how improvements can be achieved either. So here, for example, I think this should have been animated. You can see the little triangles there on the screen. Say, for example, that was a spot sample, which is what we call going out and taking a sample. Say you went every day, usually at the same time, and take a sample. That would be represented by those little triangles on the top of the graph there. What you can see behind it in orange is some ammonia data. So supposing you were testing for ammonia, you can't really capture from a spot sample, from a one-off sample, the actual dynamics, the peaks and the lows, which are the really damaging thing for the biota living in the water body. And what you end up with is a whole load of averages, which no one gets excited about averages. It doesn't help you manage the catchment, it doesn't help you get funding for the catchment either. And what you can see on the bottom there is a whole range of different data. This is from an Environment Agency probe that we were using in a wetland, one of the YSI probes you can see in the top left corner there. So the real situation is much more dynamic on a daily, monthly, seasonal event basis. So we need a lot more data in order to actually be able to manage our catchments better. And luckily, we're living in a fantastic age for that sort of thing. It's a really, really exciting time to be in this field. Better, faster, more affordable technologies. Everyone's got a smartphone that's capable of doing basic monitoring. The Raspberry Pi you can see there is leading to people creating their own software for things. That swan in the middle there is actually a water sampling swan. So he tootles around on a lake in Singapore sampling water quality. There's drones who can collect water quality. There's all this wonderful technology, and it's just not being used in this at the moment for monitoring our environment. I actually found out recently that actually the UK is probably one of the global leaders in real-time monitoring of the environment, but even we don't actually really do it to the extent that it could be done and incorporate it in every step of the process. So now we have all this technology to collect, transmit, process, visualize, and present the data to everyone, not just experts. So that leads me on to the third point, the third key reason behind INTCATCH. In the last couple of decades, there's been huge increase in what's called citizen science, so the involvement of amateur volunteers in scientific research. Absolutely explosion of it in all different walks of investigation, not just environmental. So some of the big projects you can see there, Zooniverse, for example, is actually online. You classify galaxies on the internet. You don't even have to leave your armchair. Whereas a lot of the other ones are obviously wildlife related or environment related. So another question for you guys who are listening in, have any of you recently participated in a citizen science project? I'd love to know, either yes or no, or maybe tell me what project it was involved in. There's a lot out there, and actually a lot of them require quite a bit of expertise. So, there's a huge willingness out there and ability to tackle really quite challenging issues around species identification and being very, very systematic. So there we go, brilliant, the Bristol Avon Water Blitz. Okay, great. So there's a huge willingness and ability. So citizen science is actually a resource with enormous potential for environmental monitoring, and comes with lots of extra benefits as well, such as local knowledge. There's passionate, invested participants who are willing to kind of get the ball rolling on a project and keep it going, and of course including local people in decision making about catchments and waterways issues is actually hugely useful, not just because it sort of breaks down sort of barriers to resistance, but also actually people have a lot of energy, and you can create community groups and friends of groups, and people become enabled to really start looking after their environment. So including citizen scientists in projects can have huge benefits. And here's one right here. This is Mark from the Thamesmead catchment with one of our boats. He's actually a volunteer on the INTCATCH project, and that's the other thing about including volunteers. You never know what expertise they're going to bring that you didn't know they had. This guy's actually a model plane enthusiast, and he knows far more about remote controlled handsets than I do, so actually he was really useful in helping us understand what all the buttons did on the handset, and obviously a dab hand at boat driving as well. So really good to engage lots of people. And I should also say about him as well, he's also a local fisherman, very, very concerned about pollution issues in his river, didn't really know where to turn to help resolve them, so he's very, very keen to help us. So here we are. This is just some data here from a water sampling blitz across London. So all of the dots you can see on the map are green for good water quality, amber for average, and red for poor. So this is just a demonstration here of the sort of reach that you can get for immobilizing communities to help you test water quality as well. But unfortunately, this sort of data isn't necessarily very useful for actually solving catchment issues. It's great for educational purposes and for reach, but it's a little bit sporadic unless it's very, very well designed project. And sadly, that's one of the reasons why citizen science data, despite the huge amount of energy and enthusiasm and knowledge behind it, is often currently underutilized in environmental management decisions. So I'm not going to read out the whole list there on the screen, but those are some of the biggest reasons why, unfortunately, citizen science data isn't used for management decisions or at peer review, in fact, either. So that's one of the other things that INTCATCH is hoping to challenge as well, by providing people with technology that essentially regulates itself, which therefore enables people to go out and collect high quality data. So this is what we're aiming to do: evidence-based mitigation and management, and enabling communities by bringing together various bits of technology and developing new sensors, incorporating it with a decision support system to basically create an entire system for monitoring and managing catchments, and making it much more user-friendly to enable data interpretation, collection, visualization by experts as well as non-experts. So what we're hoping to do is protect and enhance the value of our waterways, reducing costs as well. If you've got a boat, you can collect far more data in the same time frame, or even a shorter time frame than you can by sending a man out to a catchment. Actually creating effective data which will allow you to actually make decisions about where pollution is coming into your catchment, and also to help engage and empower local communities to also get involved in data collecting about catchments that they're concerned about. Moving towards this idea of smart water environments as well. So another question for you guys, if you are in the water quality industry and you in any way do any sort of water managing or monitoring, anything from actually being an agency staff member or possibly even maybe a hotelier, for example, who might be interested in the water quality outside the hotel for swimming, or even somebody who's worried about putting on an event, for example, maybe some wild swimming. Are you worried about the water quality? What are your main monitoring challenges? So the ones in the blue box are sort of really about understanding pollution sources. The writing's a little bit small on this one, but there's a lot of ideas to throw at you. Are you into public safety warnings or drinking water supply? Or maybe in the green box, you've got concerns about the sort of data quality or data analysis, or maybe you're not actually involved in water quality, but what can you tell me about what you want authorities to monitor? Is there too little data from your area? Have you actually ever tried to get any information about the water quality in your local river? Is it easy to find? Can you interpret it yourself? Be very interested to know any thoughts that any of you guys have. Or are you in a position where, yes, you'd like to get involved, and you are worried about the water quality, a bit like Mark, the fisherman I was talking to you about earlier, but you don't quite know how to go about it and what your choices are. So any thoughts you have, please put them in the chat box. Okay, so yes, identifying pollution sources, pathways and sinks. Yes, absolutely. Yes, that's the sort of key to understanding your catchments. Yes, and concerns about data as well. Some people who we've been talking to in INTCATCH say, yes, they've got lots of data. It's a question of data analysis. So we'll come on to more of these points later. So this is the INTCATCH consortium. So the project started in June 2016. We're in business until February 2020. And as you can see, there's quite a few people involved. There's actually over 20 organisations from 8 countries. From the UK, it's Thames 21. We've also got the Environment Agency as well, and Brunel University, who are actually the overall project coordinators. So that's who we are. And in terms of our demonstration sites, we've got 2 in the UK. So my role in the INTCATCH project is demonstrating the robotic boats on 4 different tributaries of the Thames in London. So you'll see those tributaries there. We're also demonstrating the boats on the Great River Ouse in Cambridgeshire. I think we've drawn the short straw because our other test catchments are the River Ter in Spain. We've got Lake Garda and Lake Yeliki as well in Italy and Greece. So we're trying to test and demonstrate these technologies over a range of water environments, from upland rivers to lowland rivers to drinking water reservoirs and good old urban London. So this is the sites for the project. So if you were to maybe get involved with INTCATCH, how would that work? So what would probably happen first of all is we would deploy the decision support system, the DSS. And what this does is actually incorporates lots of information about the catchment of interest. So anything from gradient to land use to, I don't know, where the weirs are, that sort of thing, pollution pressures. The actual sort of thinking behind the DSS is based on the DPSIR approach developed by the European Environment Agency. So that's driving forces. So that could be anything from transport or industry. Pressures on the environment would then be the sort of the pollution inputs, the state of the environment, so what it's actually doing to the river, the water chemistry. Impacts might be the impacts on the biota in the river, and then responses might be the recommended actions. So whether it's anything from a campaign for awareness, or putting in constructed wetlands, or whatever the outcome might be. So the first thing we would do potentially is make a decision support model of your catchment to help target the areas where you'd actually want to do monitoring. That's another possible criticism of the current way we monitor. A lot of the monitoring sites, not only at the end of catchments, but they've picked the same monitoring sites for maybe the last 50 years, maybe because once long ago there was a pollution issue there. No one really knows why it's still being monitored. So actually targeting monitoring at places of issue in your catchment, again, as partly a money-saving effort. The decision support system might decide you need some boats to go out to investigate the catchment. We've actually got 2 boats as part of the INTCATCH project. So we've got the Environment Agency's ARC boat, which is the green one there. So about 2 meters or so long. You've got some people there in the bottom picture for scale. And this boat was particularly developed for flood monitoring, essentially. So it will look at the sort of the bank, the channel profile, and also do current profiling as well. So it's got an ADCP on board, an acoustic Doppler current profiler, which basically sends down beams which scatter and return, and it can then look at also sediment profiling as well as the velocity of water at different depths. And what you can see on the right there is an example of some of the mapping that the ARC boat does. This was actually from the EGU meeting in Vienna, in Austria, if any of you went there recently, the European Geological Union conference. And as you can see, the red is shallower water, and the blue end of the spectrum is the deeper water. So we were actually doing a demonstration there. If any of you guys were there, you might have seen us out on the water. So depth and current profiling. And then you've got the INTCATCH boat, which is got probes on board. There's 3 different flavors of the boat, if you like. So we've got a propeller boat, which you can see in the bottom left-hand corner. We've also got a fan boat, so looks a bit like a boat from the Florida Everglades. That's more useful where there's a lot of weed and also plastic bags in the water, which tend to get wrapped around the props. So as you can see there, it's in its element there amongst weed, sticks and plastic bags. And then we've also got a propeller boat which has samplers mounted on the back. So not only can you take water data in real time from the probes mounted below the boat, but if you actually wanted to also sample the water in jars to bring back to shore to measure in a laboratory or anything else you want to do with it, you've also got that option as well. So the boat can measure the pH, electrical conductivity, temperature, dissolved oxygen. We've also got a hydrocarbon probe, chlorophyll A, and we've also got an intelligent spectral analyzer as well. So how that works is it actually looks at, it's an optical probe. It uses the absorption of light at different wavelengths to determine chemical parameters. So with that, we can look at things like total organic carbon, dissolved organic carbon, turbidity, nitrate. We're also having a go to see if we can measure phosphate and ammonia with it as well. But in theory, you could train it for anything. So another possible parameter of interest for us is something like caffeine, because caffeine obviously is a human resource. You don't get many cows and things drinking cups of coffee. So if you find caffeine in your water, it's a very strong indicator of human pollution rather than animal derived. Also as well, it's stripped out by water treatment plants. So you can then distinguish using caffeine between water that's come through a sewage treatment plant or directly into the river bypassing a sewage treatment plant. So just for example, another parameter you could potentially train it on. And when I say train, what we do is we actually take water samples from the rivers, so 20 or 25 or so samples from a particular catchment to then train the spectral analyzer on the characteristics of that river. So it does require a little bit of extra laboratory work to deploy, but it can look at a variety of parameters. So here's another question for you, a very important one, this one. We need your help to name 2 of our boats. So you can see there a fan boat in the middle and also a prop boat. We've actually got 5 boats in the UK at the moment, and we are inviting the public during London Rivers Week and your good selves to help us name the boats. So if you've got any ideas now or as we go along throughout the presentation, please add them to the chat. A couple of names that have already been suggested are up there for you to have a look at. And before you ask, Boating McBoatface was also suggested. Boating McBoatface 3 is currently on the list of suggested names. But yes, any names that occur to you, please let us know. There's no prize, unfortunately, just the happy knowledge that one of our boats is named after you, and you'll see frequent posts about it on our website. There's a link under there to the Thames 21 website for naming the boat. So if a boat occurs to you afterwards, a boat name, then please feel free to add it directly on our website. So this is how the boat works. You've got several options for controlling it. So there's the remote control handset in the top right up there, which is very useful in London, for example, where a lot of the rivers are quite narrow and there's a lot of bouncing around of GPS off tall buildings. You can also operate the boat via a tablet, which will actually then allow you to plot waypoints and generate specific courses for the boat to follow. So the idea being is you could go out one day, plot a certain course, go back a month later or whatever, and just set the boat to repeat the same course. So it has that functionality as well, and yes, for the autonomous control of the boat. On board the boat, obviously there's the sensors you can see mounted underneath. There's also a smartphone on board as a sort of backup data storage, but ultimately all of the data is managed by what we call the blue box, which is supplied by our German partner GOSIS, which controls the sensors. The sensors only really sample when they're happy, so it's a very, very intelligent bit of kit, the blue box. And then all of the data from the boat is streamed to a cloud where it's hosted, and then into our water quality model called WAYS, and from there to the decision support system. So it can then add to all of the data you've already collected about the catchment to help you make decisions. So here's some examples of some of the different autonomous plots that you could select, or you can make your own, of course. So on the top right is an example of what the tablet screen looks like. So the little disc in the corner is actually a little thumb control for the boat as well. In the bottom left is the sampling jars. So when you want to take a sample, if you've got a sampler on board, you can just touch one of those buttons and it will start filling the jar, or you can program it to sample based on limits of water quality, for example. And then in the bottom, you can see in the right dissolved oxygen plotted out on a course in a lake, or a very, very tight course with looking at temperature on the left. So those are some examples of the sort of data you can collect with the autonomous control. And the INTCATCH project is quite a big sprawling project, so we're also creating new sensors and technologies. A lot of the probes we're putting on the boat, I should say, are actually already existing. So part of the idea of INTCATCH is to bring together already existing technologies and combining it with the decision support system. But we're also developing some new sensors as well, so heavy metal sensors for copper and zinc. We're also interested in developing them for lead and cadmium as well, so they're screen printed carbon electrodes that will actually be onboard probes. And then we've got two shoreside sensors, if you like. So genomics laboratory for eDNA, it's a bit like a pregnancy test, so you just drop the water on the bottom and you get a very clear yes or no decision on whether or not you've got E. coli, for example, but we're also going to look at other bacteria as well. And then we've got bioluminescent bacteria biosensors for pesticides and various indicators of toxicity, such as, for example, tributyl tin. And the way they work is that it's bioluminescing bacteria, and then once you introduce a drop of the water sample, it then impacts the amount of fluorescing that the kit will do. And you can take a photograph of it on your smartphone. We're going to tell you what settings your smartphone needs to be on, and you can then actually analyze those data based on images uploaded from a smartphone. So the idea being that it's very, very straightforward and user-friendly, and particularly in the case of the eDNA, it will actually reduce the analysis time down from days or hours, well, days to hours, so you get a much more immediate decision. So, challenges around obtaining samples, data analysis and management. Again, this is possibly a question a bit more for people involved with water quality analysis. What are your challenges? Is it around sample acquisition? Have you got budgets limiting your ability to go out and actually collect the water quality samples that you need? Is it around modelling the data? Any thoughts on that? Are you having issues once you've got your data, is actually modelling it or validating your models with the real-time data? Or is it around data analysis? As we were saying earlier, a lot of people have got a lot of data, they just don't know what to do with it. So is that your key problem? Or perhaps you're not involved in water quality and monitoring at all. And once again, you actually care about your local river, but you're not really sure how to get started. So again, let me know in the chat, I'm very interested. So again, this slide was supposed to be animated, but you're going to see it all in one go. This boat, this is sort of illustrating how the INTCATCH project visualizes a sampling campaign. So you take your boat and you go down the river, and as you go down the river, you basically get from the real-time data coming off the probes on board various sort of fingerprints, if you like, for different types of pollution, which can be very, very complementary to data perhaps gathered by real-time fixed monitoring probes at the end of the catchment. Really help you understand where the issues are in your catchment. So once you've got your data, you've been out with your boat, you've done some bankside sampling with the test kits, you'll also want to look at the data. So what we're also developing, the picture on the right isn't a load of millennials engaged on their devices. They're not all there on their phones. They're actually looking at water quality data being streamed off a boat in real time. So Wasco is the app we're developing so that as the boats are tootling along in the river, you can actually see the data as it's coming off, as you can see on the maps on the right, which show temperature at the top and electrical conductivity below. At the moment, as you can see there, you can see where the boat's out of the water on the bridge. It's much warmer, you'd be delighted to know, and then obviously the temperature gets lower as the boat's lowered into the water. So you can see there's a line where it's carried down the bank to the left and then into the water. So as you're going along, it's raw data, so nothing stripped out, which is why you can see the data on the land as well. But if you were to encounter something as you were going along with your boat that was of particular interest, you can see that data on your mobile phone or on a tablet, and you can respond to it. So if there's a particularly nasty bit of pollution and you want to do a couple of circles with the boat to make sure you're really identifying it, or you want to stay within a pollution plume as you're sampling, you can see those data in real time using our Wasco app. And then of course after the campaign, obviously different users will want data for different needs. So authorities might want data in a different format to maybe citizens, or even just local community groups where it might even just be good enough to have a big smiley face. Yes, it is safe for your dog to go in swimming today. But what we're finding very useful is these sort of heat maps. As you can see on this screen here, this is electrical conductivity. So the bluer end is the kind of the lower range of the electrical conductivity, going up to the reds, which is very high electrical conductivity, which is usually an indicator of contaminants or pollutants in the water, or certainly an area of interest. So instantly from this, this is a Dutch canal that we took the boats on, you would instantly know from that map where to start focusing additional sampling campaigns, and that's just from the electrical conductivity data. Here's some other examples here. So we've got from our catchment, one of our London catchments, we've got dissolved oxygen, electrical conductivity and temperature for the same stretch. You probably can't see so well here, but if you zoom in, certainly there are a couple of spots indicated by electrical conductivity which seem to be higher than others, so they might represent inputs. So they would certainly potentially be of interest for later investigation, possibly known or unknown pollution sources. Your decision support system would tell you if there was a surface water drain there or maybe not. So as you can, this is how the data is all starting to build to help you understand your catchment a bit better. And something quite interesting here. So this is from one of our Italian partners. So this is Lake Garda. And what you can see in the top is a sampling campaign that took place on the 4th of October. And then underneath on the 5th of October. So 2 consecutive days. And again, it's electrical conductivity. You can see it's been quite heavily diluted. It's quite high as it comes out of the little culvert into the lake, where it's diluted and becomes much bluer. But the interesting thing in here is that on the first day, the plume is going in one direction, and on the second day, it's going in the opposite direction. So potentially, if you had a fixed monitoring stream, then you might miss or not be aware of the full extent of the issue there. So really, really nice example of sort of dynamic monitoring in action, and really nice characterization of the dilution of the conductivity as it's coming out of the water there. So these are the sort of data we are hoping to gather. I should also very briefly mention that the INTCATCH project is quite a sprawling project. We're also looking at combined sewer outfall or CSO treatments. This is one of our partners in Italy. So we've actually got INTCATCH probes and INTCATCH boats monitoring the outfall of the sewage treatment works. And we're also, SouthNest, one of our partners, is looking at filtering and treating CSOs coming out of sewage treatment plants. And INTCATCH tools are actually being used to investigate the effectiveness of various technologies, so filtration, UV and active carbon, and also natural solutions, so for example constructed wetlands, which is something I'll be involved with as Thames 21. So all these data, I know we're not looking at an extensive range of different treatment options, but these data will also be fed back into the decision support system as well to enable you to make decisions about how to monitor and manage your catchments. So INTCATCH, as you can see here in this picture, there's a little boy driving the boat, having a whale of a time. This technology is aimed to be incredibly user-friendly, so it can enable anybody to get involved, potentially leasing boats to investigate river issues. We're not quite at that stage yet. We've still got over a year to go in the project. So at the moment, we're actually really welcoming collaboration, not just necessarily in the UK, but maybe internationally as well. We're in talks with a university in Hungary, for example. We had a professor come over and visit us for a few weeks. And now we're going to take the boats over to help her with her water issues. So we're very interested in collaborating, whether you're a citizen scientist with a water issue and want some help and support, and maybe it's for us to bring our boats to test them out on your catchment, or whether you're an authority or a catchment manager. If it's any aspect of the project you're interested in, if it's the decision support, the boats, any of the new probes we're bringing on board, we'd be very interested in hearing from you, and who knows, maybe bringing some boats to your catchment. So do get in touch either now on the chat or get in touch with me afterwards. Here's some details again. So London Rivers Week is running this week. There's lots of free events in London if you're based in London. Otherwise, think about starting your own Rivers Week, wherever you are, to get people more focused on their rivers. Yep, there's the Name Our Boats link again. And yeah, those are my details there. So any questions about the project after this webinar, or if you're interested in collaborating with us in any way, I'd be delighted to hear from you. Thanks for listening.
Thank you, Natalie. That was really interesting, and hopefully some of our members and maybe project team staff will get their thinking caps on some creative names. It's really good to have somebody from the IES do that. Just generally, I know you've mentioned a few case studies where people have been really positive and really supportive as communities, but generally through not just Thames 21, but all the 20 organisations that support it, is the interest on communities quite positive? Is the uptake of their time quite positive, or do you have to really convince some communities to really get involved and kind of care about their river system?
Actually, particularly in the UK, it almost makes you want to cry how involved people are and how much they care about their local waterways and how much they want to improve it. There's a huge amount of enthusiasm, often a huge amount of expertise as well, but the thing they lack is sort of either test kits that will be taken seriously by environmental monitors. If you go out and try and do it yourself, maybe you don't do it systematically enough if you don't have a scientific background. People reject your data. We've seen this time and time again. So what people lack is a sort of structure to enable them to collect the sort of data that will be noticed. Certainly Thames 21 has lots of initiatives where we get people out planting wetlands and creating friends of groups. So it's particularly strong in the UK, which is, I think, partly why we're valuable to the INTCATCH project. But having said that, it's becoming increasingly big and recognised abroad as well. For example, Italy held its first citizen science conference last year in November. I believe Vienna, Austria and Spain, as well as other European countries, are actually coming up with a citizen science directive. So this power of citizen science is being recognised. And yeah, momentum is building. We just need to give people the tools to be able to collect the sort of data that will actually be useful.
Yeah, that's just brilliant, and you're obviously filling a niche that's definitely in need. We've got a couple of questions that have come in. If anybody else has got any more, do submit them in the chat box. But just to kick off, Andrew Davies has just asked if you could elaborate a little bit about your DSS systems, really.
Yes, it's been created by our Italian partner, Technital. It's currently not in use in London. We're hoping it will be online in the next couple of months. So some of my details about the exact specifics of it are a little bit vague, but the idea is it will basically be a cost-saving measure. So it will enable you to look at where in your catchment is most likely to have need for monitoring. So when you go out, you're targeting specific areas for your monitoring. It will also help you, if you're not an expert and you don't know, exactly how to do your monitoring. So for example, if you're interested in road runoff, it will say, well, obviously you need to go out in the rain, but also you need to monitor here, here and here, for example. So it will help guide your monitoring. And then hopefully as well, it will also help you make decisions about your catchment. So if you've got a limited budget, and you need to fix one thing for the biggest impact on a catchment scale, where would you fix? So we're hoping that the decision support system will also help to provide the evidence to present to potential funders, for example, to say, look, we've done this, this is what our decision support system says, this is what you need to fix, this is what we recommend you do. So yes, I hope that helped.
Yeah.
Always email me if you want some more information.
Yeah, and then he's actually asked another question that was earlier on in the presentation and said, are you using chlorophyll A detection as an index for hydrocarbon pollution in any of your systems?
No, we're not actually. We're using the chlorophyll probe in conjunction with things like temperature to look at algal blooms, which are obviously a big problem, for canoeists, sailors, people like that as well. So trying to predict and control algal blooms. The hydrocarbon probes is more for oil and road runoff. But I'd be interested to hear his thoughts on that.
Hear a little more. Okay. Yeah. So the details to contact Natalie are at the end, but equally, if you need some information from me, to get in touch. One of the slides, number 26, you asked for people to just submit some of the issues that they were facing.
Mm-hmm.
A couple came in, and Richard Chalkley said capturing fluctuations in metal concentration along a river course in real time.
Aha.
Common issue. And another one was obtaining representative samples is the biggest issue.
Absolutely.
Any comments?
I completely agree on that, yes. I mean, it's what I was saying about spot sampling. I don't believe they're representative of the environment, and it doesn't capture the dynamics of a river. So what you really need is data at a higher resolution, both temporally and spatially. So yes, I completely agree with both of those comments. And what we're hoping to do with INTCATCH is each of our data points, if you like, will be tagged with its GPS location, also data such as when the probe was last calibrated. So it'll be very, very robust data, and a lot more of it than from a spot sample, which will hopefully go a long way to answering some of these really tricky questions that we faced in our catchments. And yes, our heavy metal sensor, there was a bit of a debate about whether or not it was actually going to be on board the boat or a bankside test kit. Indications are that it will be on board, so it'll actually go on the boat, and yes, it can poodle down rivers and get all of those data that you're interested in.
Wow, they sound very complex little labs that are going on.
I think they are.
Really interesting. Love to see some of them. How frequently do you do demonstrations around the London area?
At the moment, the team go out once or twice a week. We're also holding engagement events. As we get more into it, we'll have more probes, and our demonstrations will get bigger. So if any of you are in London and you want to come along and see, or get involved as a volunteer and come and drive our boats, just let me know. Great.
There's been several comments about suggested collaborations from various different people, so I'll collate them for you and
fantastic.
And connect the two of you. Another question, or really a pointer, was just that it would be great to see a partnership with schools, like practical experience, maybe fieldwork, things like this, to create an awareness at a younger age. Is that something that's been discussed within the INTCATCH project, or is that later down the line?
Not at all. One of the aspects of Thames 21 is we have a big education team that do go into schools and talk about rivers and river pollution and try and encourage behavioural change from a very young age. And our boats are user-friendly. It can be used at any stage in the curriculum, whether you want to do data analysis or just very, very introductory things about impacts on rivers and get everyone down to the riverbank and have a good day out driving a boat. So it's got huge potential for schools. So absolutely, yes.
Okay, great. And one of our members has actually said that she's going into a school next week, wants to know when the Name the Boat competition closes.
We were going to close it at the end of London Rivers Week, which is Sunday, July the 1st.
Okay.
If that doesn't match and her school want to get involved with naming a boat, I'm sure we could extend the deadline by a day or two.
Okay. Again, let me know if you want me to connect the two of you. Another question that's come in from Paddy, one of our team members here at the IDS, has asked if there's any scope for testing pharmaceuticals in CSO discharge.
That's a very good question. At the moment, no. The project's already quite big and sprawling, but there's no reason why it couldn't in future. Similarly, looking at microplastics as well, that's been talked about as a possible future development of the project.
Yeah, definitely. And one thing I was going to ask actually is this technology got the scope to essentially look at open water spaces as well and kind of look into the plastic side of things in a bit more detail, or is it really restricted to rivers and lakes and small systems?
No, at the moment it's rivers and lakes, just because that's what we've decided to focus on. But yeah, another direction would be even marine environments as well. I mean, a lot of these probes have capacity for marine environments. So if there's a probe that's small enough to go on a boat and it will talk to our software, then there's no reason why it can't go on our boat. So yeah, there's all sorts of exciting possibilities for future development.
Exciting. Really exciting. Another question we've had in from Brett Fadder was, are there distributed resources for STEM ambassadors to support this initiative outside of London that you know of?
Ooh, not that I know of.
Okay.
I was formerly a STEM ambassador for the University of East Anglia, so I'm all for supporting STEM ambassadors. So not that I know of. Our demonstration catchments at the moment are London and Cambridgeshire, the Great River Ouse. That's not to say that within the lifetime of the project that the boats won't surface elsewhere in the UK. We are currently in talks with various people about potentially putting boats on their river. No, I mean, it's quite early days in the project yet, so we don't specifically have any resources for STEM or any funding, but yeah, get in touch. Yeah. Let's see if we can do something.
Yeah, and there's lots of ideas coming in about how you can expand through Roboty, but another member, Ruth, has just asked, would you consider radioactive profiles, or is that a future opportunity a lot further down the line?
Yeah, again, maybe further down the line. If there's a demonstrable need for it, then why not? Yes.
Yeah. Okay, brilliant. I'm probably going to wrap up the Q&A there. We've had loads coming in. If anybody else has got any more questions, then do get in touch with either the IES Project Office or Natalie herself, which is the contact details for her are on the screen now. But thank you all for participating, and thank you to Natalie for doing that. That was really interesting, and it'd be interesting to see where it goes from here. It sounds like it's a project with a huge amount of scope, which is awesome. Our next webinar will be Changing Behaviour for Conservation Impact by Gail Burgess on the 18th of July. So do sign up for that if you're interested. And we hope you enjoyed this webinar. So yeah, final thanks to Natalie, and thank you all for attending.
Thank you all.